Stars implode, planets grow cold. Catastrophe is the metabolism of the universe. I can fight monsters, I can't fight physics.
Hello, so M sent another question. This is a question about infrared radiation. More importantly, it's actually one of the required practicals. Okay, so basics of infrared radiation. What do we know? Good absorbers of heat or infrared radiation, and also good emitters. What sort of surfaces are they? They're usually dark, black, rough, matte surfaces, and good reflectors or poor absorbers. Good reflectors are bright, white, smooth, and shiny. Okay, so this question is basically asking you about, well, how can you work out black is a good absorber and therefore a good emitter? So if you look at the question, the student wrote the following hypothesis: black colored flask will emit more infrared radiation than the silver colored flask during 10 minutes of cooling. So straight away, just by reading that, I can work out some of the apparatus I'm going to need. So I'm going to need 10 minutes. I'm going to need a stopwatch. Okay. I'm going to measure the infrared radiation. I'm going to need an infrared thermometer. The fact that it's cooling means it must be hot, or it must be at least hotter than the surroundings for it to cool or emit the radiation from hot to cold. So that means I must put hot water in there. So you got your kettle of cold water. Clearly, the first step is to heat the kettle of water. So all you're going to do is really straightforward. Make sure you got it sort of sorted in your head before you start writing. Heat the kettle of water. Put the hot water in both of them, equal amounts at the same time or as close to the same time as possible, because you want the initial temperature to be the same. Okay, that's one of your controls. The amount of water is one of the controls also. Okay, stick a infrared thermometer, measure the initial temperature, and then 10 minutes later or every minute, measure the temperature of the infrared thermometer. And hopefully you notice that the thermometer reading on the black one is larger than the thermometer reading on the silver one. Another control factor, obviously using an infrared thermometer, it's not via contact, okay? So you got to hold it equal distances from the black and the silver, okay? So very straightforward. So let's put that in. Heat the kettle of water, okay? Pour equal amounts of hot water. In both. Okay, and then you could measure initial temperature using the infrared thermometer at equal distances. Okay, so it's one of your control factors, so make sure you write that down. Okay, and then just wait 10 minutes and measure final temperature using the infrared thermometer at an equal distance again, and then just compare, because that's all it's asking. We don't really need to do anything else. In terms of, usually with plans, do something about, safety, be careful when handling or pouring the hot water. So handling the kettle, pouring hot water. Okay, so that is very straightforward. And then clearly, if the black is a better emitter, it would have emitted the heat and thermal energy is absorbed from the hot water out into the surroundings, and the temperature of the black one will be hotter. Now, another way to do it, because it did say cooling, you could do cooling curves. So you could actually, if you wanted, stick a thermometer in this one, stick a thermometer in this one, and if it's giving heat out, both of them in this case, then the temperature of each of them would be getting smaller and smaller because the thermal energy is escaping to the surroundings. Now, because the black one is a better absorber of the heat and then emits it, okay, into a colder region, i.e. the room, the temperature of so if you drew a cooling curve of temperature against time, clearly the temperature in the flash will be lower because the heat has escaped. You're going to get two curves. You're going to get one that looks like this and one that looks like that. Okay, so and they both level off at this temperature, which will be probably about 20 degrees Celsius, because that's the room temperature, and that's where they both reach thermal equilibrium with the room. So there's no net transfer of heat either way. So this one will be the black one, and this one will be the silver one. Okay, because the black one is expelling the heat much faster, so its temperature is going to drop. Okay, so that's how we do this infrared practical.